So now we're going to look at the 6 common patterns of radical mechanisms. These are mechanisms, so we're going to be making and breaking bonds. They'll look really similar to the resonance structures we were drawing earlier, but this is not just the movement of electrons, this is the movement of bonds. Okay, so the first is a homolytic cleavage. It requires the input of energy, and usually you'll see it as UV light, and it's going to make radicals. This is a initiation step. A lot of our radical reactions are going to begin with the homolytic cleavage. So let's get a different color. And the homolytic cleavage, this bond that's connecting these two atoms, one of the electrons is going to go to live on this X, and the other electron is going to live on that X. And so we'll end up with, X and X, and they will both have a single electron, so they'll both be radicals. Coupling is the exact opposite of the homolytic cleavage that we saw above. What will happen here is that these two electrons will get together and make a bond. So we've got a single electron here, and we've got a single electron here, and they will get together and we will make a bond. Now this uses up your radicals and is a termination step. It eliminates the radical. And there we have our bond. We can have an addition to a pi bond. So this is a pi bond. We're going to break it. The pi electrons here, one of them is going to come here, and one of them is going to combine with that one. And the other electron is going to go and live on that carbon on the end. And what we'll get is this. We'll get X and with a single electron, and the electrons, I'm trying to keep my colors straight here. The electrons that connect the X to this carbon will be the ones that were involved in these green arrows. So as we can have addition, we can have elimination. Again, this is going to be just, and this is just the reverse of addition. So what will happen here, make sure I've got the these one electron is going to go live on that X, and the other electron is going to combine with this lone electron and make a pi bond. It looks kind of messy, and we will get a pi bond and a free radical. Maybe I should have used the one for the book. It looks very messy. Okay. Two more. We have a hydrogen abstraction, and what we have here is that initially the hydrogen is on the R group, and it's going to make a bond with the X. So the electrons from this pi bond, one is going to go this way, and the other is going to go that way. We'll draw it this way, it'll be easier. And the radical electron is going to combine with that to make a bond. We're going to end up with X bonded to the H and an R that's a free radical. I'm going to keep my colors constant. So all we've done here is transfer a hydrogen. We can also have a halogen extraction, and it works very similarly. One of the electrons is going to go here. The other electron is going to end up on the X. And the lone electron is going to combine with the electron from the other bond, and we're going to end up with our R group, and it's going to be bound to the X, and then the other X is going to have a radical on it. So we've just switched a halogen around. So the steps for drawing these fish hooks are, first, that you need to ID which of the processes you're involved with. Note that they all have 3 arrows except for the initiation and the termination step. The homolytic cleavage and the coupling have 2 arrows, but all the others, you need to have 3 arrows. That helps keep you straight. Identify the bonds that are broken and formed. Each formed or broken bond will need 2 arrows because it has 2 electrons and they're coming from different places. So let's draw the fishhook arrows for the following radical processes. So first we want to figure out which bonds are being made and broken. So we're going to break a bond that's between the hydrogen and the bromine. That bond is going to get broken, and we're going to make a bond between this carbon right here that I'm doing in black and the green hydrogen. So those are the bonds we're making and breaking. So this radical, well, so this bond is going to divide. We're going to get one that goes off this direction and one that ends up on the bromine. This electron is going to combine with the electron from that bond and make a new bond. In this one, the second one, we're going to break. This pi bond is going to be broken, and we're going to make a bond between this carbon and the bromine. So in this bond, in the pi bond, one of the electrons is going to go live on this carbon over here, and the other electron is going to combine with our radical. The third example, we're making a bond. We're not going to break any bonds at all. This is a coupling, so we'll only need 2 arrows. The lone electron there will combine with the lone electron here and make the bond. So you need to remember that when we initiate these radical reactions, we start with a homolytic cleavage. That makes radicals. The propagation steps are addition, elimination, hydrogen and halogen extraction. And then termination is the coupling step. This uses up or gets rid of radicals. And next we'll look at the chlorination of methane.